Okay, in this class we'll start with module 2 concepts. The slide is visible, right?
Yes, sir.
Yes. We'll start module 2. These are the contents from module 2. In this we'll study with prefabricated elements. Basically, you'll be knowing about the different types of elements, what they are going to manufacture in manufacturing site or in factory, especially with respect to this prefabrication. So in this, different elements will be there. Here we are going to study how they are going to manufacture those and how they are going to erect and other relevant processes. Okay. So here the different structural prefabricated elements are like roof and floor panels, ribbed floor panels, wall panels, footings, and the most important concept is the joints for different structural connections. So here you'll be having various structural members. They are going to connect with each other, and which type of joints we need to provide, and which and how exactly we need to provide those joints. Those things we'll be studying. And next, effective sealings of joints for waterproofing. Not only with respect to this waterproofing, even with respect to the reduction of the stresses, we are going to provide the effective sealing of the joints. Means once you connected two different structural members, it is going to form certain gaps between the structural members, right? That one we need to seal it by different adhesive members. Yeah, so that it is going to reduce the leakages or other irrelevant things like the cracks developments and all, and even we can increase the durability part of the structural members. Okay, and then the provision of non-structural fastenings means is going to carry certain loads, especially they are going to use in the kitchen and all. Okay, so there, which is going to take the load from the wall itself, but the connections between the walls as well as the other required elements, we can provide those connections. No, that one we can call it as fastenings or fasteners. That one also we'll study here, and then the expansion of joints in precast constructions due to the temperature variations and all. The joints it will get expands or whatever the additives you have filled or else the grouting materials, so which is going to change in its volume, and so we are going to provide some additional space for the joints in the precast construction. And then the construction of precast structural components like purlins, principal rafters, roof trusses, lattice girders, gable frames, single span single storage frames, and then single storage buildings, and then slabs, beams, as well as the columns. So these structural members will see in this model 2. Okay, we'll start with the first part. So roof and floor panels. Okay, the first structural element we'll study with roof as well as the floor panels. So here this system consists of RC planks as well as the joist. So here RC planks are nothing but the horizontal members. They are acts as the platform to the slab, and it is going to consisting of certain gaps in between the structures like this part. So these are the RC planks, so which is going to provide the clean surface on top of the structures, and within this which is going to consisting of the hollow portions. Yeah, so here these RC planks, they will be having certain gaps in between the structures with the regular intervals, like the from the interval in the sense the gap between one whole portion to the other whole portion. Okay, so here these planks which are casted to a standard size means they are readily available in the manufacturing site, depends upon the various thickness. So basically the thickness of slab will remain same for most of the buildings. So even in the manufacturing site they are available with the standard sizes with respect to thickness as well as with respect to length of that member, the total length from here to here. So they are manufactured with fixed dimensions. and they are connected with RCC joists which are provided at regular intervals. So here in this particular whole portion, those joist members will come, I mean the vertical members. So here it is going to fill it by the joist member. Okay, these are the RC flanks, and within this the joist member will come, so that whatever the load which will comes on this RC planks, which is going to transfer to this RCC joist, right? And then that joist, which is going to rest, I mean, which is going to support the entire load on the side walls or else on the beams. Okay, depends upon the convenient portions. Those joists are transferring that entire load of this RC planks to the required location. Okay, and then here the load which are transfers from the planks which are transmitted to RC joist and then to the main beam. So here you can see in this part, okay. So here you can see the part, these are the joist, I mean the vertical members, sorry, horizontal members, what you can see, these are the joist, and within this portion, that RC plank will come and fix, okay. And then in some cases, they have provided with the circular in its shape, and in some cases we are going to provide with square or rectangular. Okay, depends upon the convenient of the RC planks, they are going to provide those joists. In most of the cases they will provide circular only. So in this case, this particular joist portion they are going to fix within that RC planks, so that that RC planks load will come first on this joist, and then this entire load whatever it will comes on this joist, which is going to provide on this vertical members called studs. Okay, so these studs which is going to carry both the loads which will comes from RC planks as well as the joist, and then which is going to rest on the beam or else floor. Depends upon the floor, they are going to transfer that entire load. Okay, here also you can see the joist again within this, the flow member will come and fix, that is only RC planks. Yeah, and here the joists which are seated in the channels are bolted together. So in some cases when you have used the steel structures and all, they are going to connect with some nut and bolt connections, and when these concrete members they are fixed together in the sense those resting those particular RCC joists which are resting on the wall panels, there they will be having certain connections between them, like they are bolted with certain nut and bolt connections, and then they have routed with some adhesives. Okay, and here you can see these RC planks how they have placed. Okay, and this is the erection process. There, as I told, depends upon the length of the member and the weight of the member, that erecting equipment is going to be chosen, and then the providing of these supports while erection or else these hook connections what they have placed here. So that is depends upon the total length, and depends upon that they are going to fix these erection connections to them, and then standard supporting members also they are going to provide here. So whatever the stresses which are going to develop within these members initially, which is going to taken care by these additional members which are provided on top of this RC planks. Okay, and then they are going to erect. So only the thing is which is going to hold this particular portion. You can zoom it and you can see so that the things will get clear. Okay. So in this particular portion, which is going to fix it properly, and whatever the stresses which will get developed within the erection members as well as the structural element, that is going to taken care by this additional member, so that the stresses which are going to be reduced here. And then moving on to the next part, that is joist. So these joists which are designed as a small beams loaded from the planks. As I said, these joists which are like which is going to consider the load which will comes from the RC planks. Okay, and then the joist they are going to transmit the load to the main beams through the channels which are provided in the main beams. So here whatever the beams they are going to provide, again the horizontal members will come. So these joists which are resting on top of that horizontal members. So this load which are going to transfer vertically through the respective members like beams and then studs and then to the floor members. And here the assembling of planks and joists that is going to give the monolithic actions, and this system will act as the continuous slabs over the joist. Okay, so here once they have fixed with this joist as well as that RC planks, which is going to give the monolithic structures, means it's like a single slab what you can see. Only the thing is to give the proper connections between these joists as well as the RC planks, that is going to give that entire whole member called slab, right? And here after this part, the next member will comes the wall panels. And before going to this wall panels, just we'll watch a small video regarding that RC planks as well as that erection process. Okay. This video slide is visible now, right? Video part.
Yes, sir.
Yes, sir.
Yes. So in this you can see how exactly that RC planks have been placed in the during the construction part. Okay, these all are the structural members, and here you can see. I think my cursor is visible to you, right?
Yes, sir.
Okay, so these are the RC planks which are acts as the slab members or else the floor members. And before placing this, you can go with various other things like providing of the plumbing or electrical work, whatever the convenient concepts you need to adopt within that slab members. You can plan well in advance, and then you can put those additional members whatever you required. Okay, so here these are the members which are going to give some other applications like electrical connections and even some plumbing connections too. These are the erection process which you can see, and here you can see as per this particular member they have give certain additional space for this, so that one also you can provide some special circumstances. And after this particular portion, whatever the gaps will be formed, no, that one they can fill it by some additional members. And even if you want to go with some additional works, again you can go with respect to that. Here they are going to make certain drills so that some other connections also they can provide. So these are the flexible ones. And even while during the erection process, see this is the during the erection process how they have provided the connection. And here in this part you can see they have marked certain things here. So based upon that mark, they are going to place these supporting members of the erection equipment. Here you can see from that blue color mark, right? So based upon that reference line, they are going to fix those erecting equipment supports. This is placing of the RC planks, and within this particular whole portion, joist will come and fix. And whatever the gaps which will be formed here, so later they are going to adjust this one as per the requirement, and then they are going to fill some grouting materials within this particular gap portion. This is the erection process of this RC plank to the required location. In this part we can see these all structural elements, they are with a standard size, correct? So only the thing is wherever you require some additional members depends upon the size. When if it is fixing with some standard dimensional RC planks or joists, that one you can fix else. Again, you need to give certain orders to them as per the requirement, and then they are going to manufacture as per the client's requirements. Okay. You can observe here all the structural member of RC planks as well as the joist will have the same dimensions, even with respect to length of the members and even with respect to the thickness or even with respect to width, right? We'll be having some standard dimensions. Then even they are going to give the directions to the crane operators. So just through the hand signals here, right? So that as per his directions, he is going to move that one. You can see the various other connections just below this slab members. You can see here. This is just one example part. All the slabs, it won't work as per this. Thing is like as per their applications, they have provided certain additional members within those slab part or else the floor parts. So this is how they are going to provide or they are going to install these floor members. You can see for everything you should require certain spaces, right? Just to place for the erecting equipments and other general considerations over here. Okay, later these gaps and all it can be filled by some additives like joints. I mean some sealants, what we can call, so that you can reduce the leakages within these members. The main concept of joining these two parts will be which type of adhesives you are going to use, right? It should not get expanded. So those other properties and all will be there. When we are going to study about those jointing materials, that time we'll discuss those. This wall panel slide is visible, right?
Yes, sir.
Okay. So here, these wall panels basically they have classified as load bearing walls as well as the non-load bearing walls. Okay, we will be knowing about this load bearing wall as well as the non-load bearing wall. Those will consider, I mean, those who are taking certain loads from the top structures, they are considered as the load bearing walls, and non-load bearing walls are like only they are going to consider its self weight. Okay, like partitions, walls, clear, and compounds. Those all are considered as the non-load bearing walls. Means no additional loads which is going to consider on top of this. Okay. And here the wall panels which are casted with all the fixings like door, ventilators or window frames depends upon the convenient places for the doors and windows they are going to manufacture. Okay. And here depending upon the structural design considerations, these prefabricated wall panels classified as cross wall system as well as the long wall system. Okay, So here the cross wall system, the first part. So in this scheme, the cross walls which are non-load bearing walls, sorry, which are load bearing walls, whereas the facade walls are non-load bearing walls. Okay. So here first you need to consider which are the cross walls and which are the facade walls. So you can refer these diagrams here. So these are the facade walls which are exposed to the outer surfaces, and here in this case these are the cross walls. So in this case, these cross walls which are going to take the load which will comes from the top structures. So they are called the cross walls, right? So basically these types of cross wall systems, they are going to considered in high rise buildings, because in high rise buildings, so whatever the loads will comes from the slab, that is directly it is going to transfer on this cross walls. Okay. So in this diagram also you can see, so here these are the cross walls here, which are just provided perpendicular to the facade walls. Facade walls in the sense which are the front walls, what you can see, which are exposed to the outer sides. Clear? So for that, whatever the walls we are going to provide, and then which is considered as the load bearing walls. Yeah, they are considered as the cross wall systems, and basically they have provided in the high rise buildings due to the load consideration systems. And then the long wall systems, and even we can call it as a diaphragm wall. Yeah, so which are like a facade walls in some cases. These are considered as the load bearing walls. Clear? So this one even we can provide. I mean these types of long wall systems we can provide for low rise buildings, or else we can provide this one for smaller structures. Okay. So in this case, the cross walls are the non-load bearing walls, means whatever the cross walls here they have provided, they are non-load bearing walls, and then whatever the load which will comes from the stop structures, that is going to transfer through this diaphragm wall, or else even we can call it as a facade wall, or else the long wall system. So this is the entire long wall what we can call. Okay. So here this system which is suitable for low rise buildings, and a combination of the above system with all the load bearing wall, they can also be adopted. So it depends upon the convenient load convenient, even we can go with the cross wall systems, sorry, even with the long wall system also. Okay. And here if both walls and floors which are cast in situ in the reinforced concrete, the series of boxes which are formed, that is sometimes referred as the box frame construction. So here in some cases we can go with the long wall system as well as the cross wall system also. So in that case, this all the members which are considered as the load bearing walls, so that time we can call it as box frame construction. So just for that is for the additional information. And then the long wall systems, the construction which is very typical, right, with the large block structurals and special pier blocks which will comes between the windows, and that is going to carry certain loads from the lintel also, right? And then these horizontal still, these blocks are which are not loaded, and in some designs the space between the piers that is filled by the prefabricated unit, that is consisting of RC window frame, that is with the complete window what you can see between the wall panels, I mean in between the wall panel portions. And here you can see the difference between the load bearing walls as well as the non-load bearing walls. Basically these load bearing walls which will gain certain loads from the top structures, like this is the roofing system, these are the principal rafters here, and so the load which will come from the top structures, which is going to transfer to the walls which are considered as the load bearing walls. And here you can see the non-load bearing walls, you can't see any top structures or load which will comes from above this particular wall portion. Yeah, so these are the non-load bearing walls, and these non-load bearing walls just they have provided to separate the wall portions. Yeah, and no other advantages will be there, just to maintain certain gaps or the dividing portions within the room sections they have provided, and certainly they are not going to take any additional loads on top of that. And here also you can see the load bearing walls, whatever the roofing load which will come, so which will transfer to this load bearing walls, and then these load bearing walls later they are going to transfer that entire load to the floor or else to the ground. Okay, and here you can see the storage of wall panels. So in the manufacturing site, or even you can see in the construction site before the erection process. So the care must be taken to provide this, I mean to store these wall panels. Here you can see, if you remove these wall panels, you can see the additional members which are provided in a triangular portions, and then even you can see the certain supports. Directly they are not going to rest on the ground itself. Clear? And then here between this one member, I mean this triangular portion, that is additional supports to this wall panels, they have provided some additional members between that, and these triangular portions will be having that inclined in its structure, so that whatever the load or stresses which will be get developed, which is not going to cause anything to the other members. Yeah, so here within this particular, I mean whatever the triangular portional support you can see here, between this and the structural element they are going to provide some additional members which are made up of wood or steel members, so that no other stresses will get developed between this member to here. And then providing of the proper platform, that also reduces the stresses. Okay, here you can see that's the proper platform without any undulations, and the even surface is what you can call. Okay, so this is the erection of the wall panels, and here you can see they are going to provide some space for openings like wall portions. Can you see this part? So this particular portion which is provided for the wall portions, and then as per the requirement you can provide those openings at which position you require, from which, at what distance you require that wall, and also those things comes under in the design concepts. As per the client requirements they can provide the openings for them. Then here you can see the installation of these wall panels. While installation process, first you need to check where exactly you need to provide the connections here. So directly you can't provide on top of this. See here they have provided certain openings in the wall, and then through that openings they have given the certain connections. Yeah, and then here while providing while installing these wall panels, they need to check the proper connections, because on the ground floor and all they have provided certain additional reinforcements. So just through these additional reinforcements they will come and fix. Okay? And then those joints and all, which is going to provide within these gap portions, whatever they have provided here, the gap portions they have provided, and within that gap portions these additional reinforcements will come and fix, and then they have fixed with some grouting materials. And then after the installation process, once you filled with the grouting materials and all, here you can see that additional supports, what we will call for this, can somebody tell? For this additional supports, yes.
Retaining wall structures.
Not retaining wall, I'm asking just this portions, I mean these members. Yes, we have studied this.
Scaffolding.
Not scaffoldings.
There side walls, I think.
No baba, not sidewalls.
Farmer.
Technical term is there for that. Yes, just try at least others. Yes, just you can try. What we will call for this supporting members? You have studied in BMCT. Supporting
Shoring,
members,
sir?
shoring, right? So
Yes,
these
sir.
shorings again they have classified as a single shoring and double shoring will be there. So these shorings they have provided for these vertical members just to provide some additional supports. Even some structures which are going to be what I mean restored. I mean some rework has to be done on those structural members. That time also they are going to provide these additional members. Okay. So after providing of the structural elements with proper adhesive members, they are going to provide some shorings just to provide the additional supports to these members. And after certain period of time, they can remove these supports. Okay. And this is the erection of wall panels during high-rise buildings. In this case, you need to be concentrate more on selection of the exact place for the connections here, and even the capacity of the erection equipment. Okay, and then shear wall concepts. So, what do you mean by shear wall? Clear words. So, shear wall is just like a structural member, especially that is used to resist the lateral force. Yeah. So, whatever the force which will get through the horizontal mode, those forces it is going to resist by these shear walls, like that is parallel to the plane of the wall. Yeah, for slender walls where the bending deformation is more, that time these shear walls which are going to resist the loads, that is due to the cantilever actions within these members. Okay, and here you can see the two-way hollow core precast panels which are there, and they are going to fix this one within this cast in situ reinforced concrete, so that which is going to provide that whole member once you join this element to here. Yeah. So here these shear walls which are vertical elements of the horizontal force system, force resisting systems, what we can see here. Okay, and then moving on to the next concept, that is beam. And here all the main and secondary beams are of the same size, that is 300 by 300 mm. Okay, and that is going to varies that reinforcements which are provided at various conditions according to the moment. So here most of the beams which are going to be manufactured in the construction or manufacturing site, that is with the same size 300 by 300 mm, they are readily available in the manufacturing site. Okay, because here as per the design concepts, whatever the reinforcement they are about to give, they are all matching with those standardizations what they are going to prefer. So if you want to change the beam size and all as per your design convenient, you can change with your requirement, so that that cost of availability for the special type of members it will be more. Okay, so these members they are readily available 300 by 300. Okay, still if you want to change as per your requirement or as per the design concepts, you can change it. There is no problem in that, but the thing is like that cost of manufacturing for the special type of the elements it takes more cost. Okay, and here the beams are casted for the clear distance between the columns. Here these beams and all they are going to manufactured as per the column sections which are provided, and the thing is like depends upon the load consistency which type of beams you need to provide, that also which will comes under in design concepts. So here you can see the different types of beams, that is rectangular beam, L-shaped beam, inverted T-beam, and then this ashto beam. So the ashto beam is nothing but this American Association of State Highway and Transportation Officials. So in this case, this ashto beams, I mean this the term ashto, what they are going to do in the sense they are going to prefer certain standards which are going to set the body that is going to publish the standard specifications, and then the test protocols, and even the guidelines while they are going to follow during the manufacturing process and even the erection process. Okay, especially these are going to be prepared for the highway design concepts. Basically, while providing off bridges and all, they will prefer these types of beams. Okay, and next here you can see the L-shaped of beam they are going to manufacture, and then they are going to erect that one as per the requirement. Okay, and then here you can see these ashto beams. On top of that also they are going to place the concrete, and then after the erection process also they are going to place that concrete. And here you can see the common beam, that is rectangular beam, and then this inverted T beam sections. Like these are the different types of the beams as per the requirements, and even these inverted T beams they will give. I mean, they are going to manufacture these types of beams, especially due to the additional load considerations. Like these particular slabs, which are going to resist on this inverted T beam sections, means on top of this portion, and then this is going to take certain loads, and then they're going to consider this entire load to the column here. Okay, so this inverted T beams, even which is going to helpful in the joining part of slabs as well as the beams connections, and here will get certain connections, and then these gaps which can be filled by some sealants or the adhesive members. Clear? During when the load carrying capacity you require more, means you need to prefer these types of inverted T beam sections. Okay, these are, you can see the rectangular members, what you can see. So we'll watch a small video regarding this prefabrication, I mean in the beam part. This video part is visible now, right?
Yes, sir.
Okay. In this part you can see the beams they are going to erect that one from the transportation vehicle to the required locations. It's just a time lapse video. They're going to consider a lot of care while installation and even while placing of that, because as per the design and dimensions they need to place exactly to that. Here you can see so many obstacles it may falls by these retaining walls. Within this you need to fix this properly, and even you can see some additional precautionary things to this erection equipment. It requires some hard starter just to place this entire load. I mean, whatever the reversible load it will get applied, right? So that one it can be resisted properly. Like this, the number of elements they have installed. Yeah. The last members, for the class members, that crane came on the ground floor here. After placing these beams, it looks this way. Okay. So we have seen production stages of, production types of prefabrication. Which are those? Can anybody remember? Understood my question, right? In first module, we have seen production of prefabrication. Different types of methods we have seen. Tan method, belt method, or conveyor method. Remember?
Aggregate method, sir.
Very good. Aggregate method, the last one. So in that, we got a small video clip regarding the stand method. We'll watch that concept. Okay. Video study is visible now, right?
No, sir.
No, sir.
Now?
Now
Yes, sir.
visible, sir.
Yes, sir.
Okay. So you can see in this stand method, this is the manufacturing site. You can see the various stands. They are fixed at one position. You can go with various structural elements. Here, this particular stands which are provided with the standard openings for that. Here, so here you can see the standard openings as a window part here. These are the fixed modes, and as per the requirement, you can change this one. Now the manufacturing process will get started here. Initially, the stands, whatever you can see, they are fixed, and in additional part, which is going to move from one place to other place here. So in this case, you can see they are going to provide some cleaned area on that, and then now, as per the openings, they are going to mark where exactly they require the marking system and all. Then they are going to mark on that proper platform, and then they will place the reinforcements just by providing those in those gaps. These are the mounts they are going to fix now. So as per these dimensions here, they are going to fix the openings there. And then they are going to place the reinforcements, then covers. Now the concrete will pour in this section. After placing this, even you require compaction also. Just you understand this is animated video. You won't get the proper clean surface once you place the concrete in this way. Just understand the concept behind this. So after the concrete will get hardened, they're going to place the one more layers also here. That is for the additional purpose. Like some gaps what you can see between the wall panels, so that it will help for the thermal expansions, and even you can get the cool air within that sections. In the manufacturing site itself, all the members have to be manufactured. So this method like this, you can see, right? Then even the finishing process also it can done in manufacturing site itself, and even you require some paintings also, it can be done there itself. Then it is going to shift to the required location, like for storage areas. Again, after the demolding process, can erect that one to the required location. Like that, they have provided, they have sent that one to the storage place. Yeah, this is the stand method what we got. Yeah, for today it's enough. The things are getting clear, right? From the module 2, the so many structural elements will be there, and as per that, we are going to study one by one. Yes, just place your name and USN. If you're having any doubts, you are free to ask the questions. If you don't have any doubts, just can disconnect the call. Atiya and Neha, just place your name and USN, and then you can disconnect the call. Atiya and Neha. Atiya, you there?